Let's try to have a better understanding of all this theory using a Python example for polyphase. So we will assume our signal x is equal to this array of numbers 5, 6, 7, 8, 9, 10, and we use n equals to 3. So then we get the signal blocks if x of m, with m in a range as we need to fit the signal. So x0 will be 5, 6, and 7, and x1 will be 8, 9, and 10. We can use Python SymPy, and we use three-dimensional arrays or tensors to represent the coefficients of the different exponents of z in the third dimension. So now we are going to use SymPy. I'm defining here z as a symbol, and then the polyphase matrix now is a row vector with two blocks. So I'm defining here first xp, so zeros. So this is the size as a three-dimensional array, and then we have this x zero here is with 0, and then we have 5, 6, and 7, and here is 1, and we have 8, 9, and 10, and then we'll add these two, but this one has a coefficient for z to the power of -1. So we end up with this array here, and we have 5 plus 8 z to the power of -1, 6 plus 9 z to the power of -1, 7 plus 10 z to the power of -1. So the polyphase elements x n of z with phase 0 n from 0 to n-1 are given here. So the polyphase vector is, so we have this element here, this element here, this element here, and we have this polyphase vector. So we see that it corresponds to exactly the same as our Python output. Assume we have the first analysis impulse response given by h of 0 is 3, 4, 5, 6, 7, and 8, and for n equals to 3, then its polyphase vector is in general even here, with our phases going down. And for this example, we'll take subband k equals to 0, and then we have this definition here. So in Python, again, we can calculate this. So the H polyphase matrix is a column vector with two blocks, and we are doing 5, 4, 3, 8, 7, 6, and then we're again we have this 0 and 1, and we multiply the 1 with z to the power of -1, and we will get this here, which is identical to what we have here. So filtering with downsample as a multiplication of the polyphase matrices x of z and h of z is done here. So what we're doing is we are doing a dot multiplication x of z and h of z, and what we have is this result here. So this is the filtering with downsampling as a multiplication of the polyphase matrices x of z and h of z.